Hello everyone, let's take a look at this LeetCode problem. It's the last problem in the weekly contest, but this time the weekly contest is not as difficult as previously. Let's take a look at. Okay, so the problem is this: if you haven't read this problem, you can take some time to read. So the idea is very simple. We have to pick an element at index k. Then we can include some elements before k and include some elements after k. So we need to get the maximum value of this formula. Okay, so let's say this is input. So k is 3, which means we have to pick 3. So at this time, mean element in my range is 7. And my answer is 7 so far. Okay, next time I can pick some element before it and after it. So this time I can pick 3 or pick 4. Obviously, like pick 4 is the better solution here, since the width is always 4, but the minimum value is a little bit larger here. So we pick 4. Mean element is 4. Answer is 2 multiply 4, which is 8. Okay, next time we pick 5, since 5 is greater than 3. Okay, so mean element is still 4. Answer is 4 multiply 3. Okay, next time we have to pick 3. And answer is 12. Next time we pick 4. Answer is the mean element, which is 3, multiplies width, which is 5. So next time we pick 1. We know the answer is 6 this time. So we should still keep 15, since we need to keep the maximum value here. So the code is pretty simple. We need to have 2 local variables. One is to maintain the mean element. One is the answer we need to return. And we have 2 pointers. One is I, one is j. Initially, they point to k. So as long as we can still include some element previously or include some elements at the end, we will keep the while loop. If I is 0, which means we cannot pick elements at the start, then we have to pick j, right? Or the element at I is smaller than element at j, so we need to pick j. So when I is 0, or when nums I minus 1 is smaller than nums j plus 1, we need to pick the elements after j. So we update the minimum value and update our answer. Then in the opposite, we can move I. So we can pick the element at I. So we need to decrease I by 1. Then we try to update minimum and update our answer. So it's just a pretty like 2-pointer plus greedy algorithm. Okay, that's it. Thanks. See you next time.